In this tutorial, we're going to be looking at integration by direct integration. How do we solve integration directly just by the general method of solving integration? Let's get started. We have already established that if you have an expression which is dy over dx which equals to x to the power of n, then y equals to the integral of x to the power of n, and this equals to x to the power of n plus 1 over n plus 1 plus c, where c is the arbitrary constant. And we also know that integration is simply the reverse process of differentiation. Now we'll be looking at our first example. The first example states evaluate integral of x to the power of 5 dx. And I would like to do something. I would like to further elaborate this better to see where this expression is coming from. How do we get to this point? Let's assume we have been given an expression f. We have given an expression y, which is a function of x. And from differentiation, the derivative of y equal to dy over dx. And this equals to x to the power of 5. Here, if you cross multiply, we are going to have dy equal to x to the power of 5 dx. So if you integrate both sides, this is integral of dy equal to integral of x to the power of 5 dx. So integral of dy equals to y equal to integral of x to the power of 5 dx. So this doesn't mean a lot, it's just to show us where the expression x to the power of 5 dx is coming from. So what we have to look for now is our y, which is equal to x to the power of 5 dx. From what we wrote in the previous slide about the general solution of integration, we have here that y equal to x to the power of 5 plus 1 over 5 plus 1 plus c, and this equals to y equal to x to the power of 6 over 6 plus c, and this is the answer. So this expression y equal to f of x is simply this. So therefore, if we differentiate y, which is x to the power of 6 over 6 plus c, we are going to have x to the power of 5. To show you a quick tip of how to easily get this, let me talk about this. For example, now we are given y equal to integral of x to the power of 5 dx. So one way to easily get this is to assume dx is just multiplying x to the power of 5 by x. For example, we are multiplying x to the power of 5 times x. Just like try as much as possible to remove the d and put x here. So we can have that x to the power of 5 times 5, we are going to have x to the power of 5 plus 1. And simply put whatever you have at the top, put it at the denominator too. 5 plus 1 plus c. So this is a quick tip of how to easily get integration. This is x to the power of 6 over 6 plus c. We have another question here. Question 2. Evaluate integral of 1 over x to the power of 3 dx. So we don't need to talk about where this is coming from again. Let's just go to our question straight. So we have to integrate 1 over x to the power of 3 dx. To make this easy for us to work with, let's simplify 1 over x to the power of 3 to the simplest term. And this can also be written as integral of x to the power of negative 3 dx. So now we have to integrate x to the power of negative 3 dx. And as I told you in the previous question, just assume we are multiplying x to the power of 3, x to the power of negative 3 by x. So we are going to have y equal to x to the power of negative 3 times x, and this equals to x to the power of negative 3 plus 1. This is coming from indices over whatever you have as the power, you bring it here, minus 3 plus 1 plus c, and this equals to x to the power of negative 2 over negative 2 plus c. Then you can further simplify this as 1 over negative 2 times 1 over x to the power of 2 plus c. This is coming from indices, and here we are going to have minus 1 over 2x to the power of 2 plus c. And this is simply the solution. So y equal to negative 1 over 2x squared plus c. This is the third example, and here we have some trig functions. The question states evaluate the integral of 3 cos x plus 4x to the power of 5 dx. So let's rewrite this. We have the integral of 3 cos x plus 4 to the power of x to the power of 5 dx. Now we're going to do some things in integration now. If you have an integration like this, where you have an expression plus another expression, it is possible for you to split the integral into two. So here you can say that this equals to integral of 3 cos x dx plus integral of 4x to the power of 5 dx. So we can solve this individually and get our final answer. So here we have a constant c, 3, and we have a constant 4. What we can also do is to bring all our constants outside the integral. So we are going to have 3 integral of cos x dx plus 4 integral of x to the power of 5 dx. And then we have 3 into bracket. So it has already been established that the integral of cos x dx equals to sin x. This is sin x plus 4 into bracket. So we are integrating x to the power of 5, just like we had in the first example. Assume that we are multiplying x to the power of 5 by x. So we have x to the power of 5 plus 1 over, let's put whatever we have at the top at the power here, 5 plus 1. And this is plus c. So we now have 3 sin x plus 4 x to the power of 6 over 6 plus c. And here we have 2, we go here in 2 times, and 2 we go here 3 times. Then we can have our final answer to be 3 sin x plus 2 over 3 x to the power of 6 plus c. And this is the answer to the question. This is the last example you are going to be looking at. The question states evaluate integral of 4x minus 3 exponential x dx. Just like we did in the previous example, if you write this as 4x minus 3 e to the power of x dx, we can split it into integral of 4x minus integral of 3 exponential of x dx. And to bring out the constant, we have 4 integral of x dx minus 3 integral of ex dx. Now, for the first part, we have 4 into bracket. So what's the integral of x dx? So assume we are multiplying x by x. So we have x 1 plus 1 over 1 plus 1 minus 3. The integral of e to the power of x is the same as e to the power of x. It's just like a divine answer. So you can check out how to do that from our tutorials. Plus c. And then we have 4 into bracket x to the power of 2 over 2 minus 3 e to the power of x plus c. And this equals to 2 x to the power of 2 minus 3 e to the power of x plus c. And that's it. We have come to the end of this tutorial. I have some exercises for you here, as I promised you. You have 3 exercises, the first, second, and the third one, and the answers are also given below. Try to attempt this, solve them on your own. If you have any problem arriving at these answers, you can post your question in the comment section below, or reach us at rolesacademy@gmail.com. Thank you.